so I said we're going to do systems, and we are, in kind of a different way, not just straight up systems of equations, because these first few are systems. And I know it may be hard to read the board from where you're sitting, but it's the exact same piece of paper, all right? If one of the things we're going to talk about in class today, and some of you have been to class already and some of you haven't, but is how to make sure you're working harder and not smarter. Don't jump in and try and just solve everything outright at the very beginning. Also, don't assume because it looks weird that you don't know how to do it, okay? So, well, let's look at number one. It says both x and y are positive integers. First of all, make sure you know what positive integers mean, because that can make a difference in some of these, right? Integers are your counting numbers, and they're only the positive ones. So if x plus y squared equals 144, and x times y equals 35, then x squared plus y squared equals blank, right? So, does this right here equal x squared plus y squared? Do I just square x and square y? No. Is this a special case? It is, and the special case is a little bit easier maybe when you're multiplying than when you're factoring, but either way, even if you don't notice that it's a special case, you should be able to multiply it correctly, right? This is a perfect square trinomial, right? And that just means that my pattern is, that was the pattern that looked like this. A squared plus 2ab plus b squared, right? So since this is x and y, that means that's going to give me x squared plus 2xy plus y squared equals 144. Okay. Now, you should be able to multiply that out some. Even if you can't do the shortcut, you should be able to get just right there. It gives us xy. I don't need to solve for x. I don't need to solve for y. But they gave me this. Can I substitute that in? Yes, you don't have to get all the way down to x and all the way down to substitute. If x times y is 35, can't I substitute it in right there? So I get x squared plus 2 times 35, 2 times 35, 70, plus y squared equals 144. Okay? And then what I want is x squared plus y squared, so then I can just subtract the 70 from that, and what do I get? 74. And you don't have to show the work, right? So you don't have to actually show that you're subtracting 70. You can just get to that, and your answer is 74, okay? Do you see how that wasn't that bad? But you do have to be able to multiply binomials, okay? But I didn't have to factor anything. I didn't have to worry about what do I do if it's x squared plus y squared, and we're good. All right, good? Yes. What did you do? Mm-hmm. Mm-hmm. Okay. Good. Did y'all follow that? Do you want me to repeat what he said? Okay. So what he did was he said, and that's absolutely fine, and that's why this is a reasoning test. It's a different way to reason it out. And his reasoning had a lot less of the actual algebra and work that you have to do in it, but not everybody can always follow those things. But yes, so if x plus y squared equals 144, then x plus y equals 12. And it did tell us they were positive integers, so I don't have to worry about the the square root being negative or whatever. So if x plus y equals 12 and x times y equals 35, this is also a system that I could solve somehow, but what he did was find all the numbers that would add to give me 12, right? And see which ones would multiply to give me 35. So it could be like 1 and 12, 2 and 10, 1 and 12, 1 and 11, 2 and 10, 3 and 9, and went through it like that. He didn't write it down, but he was going through it in his head, right? I'm assuming he didn't write those down. And then you got to which two numbers? 5 and 7. So 5 plus 7 does equal 12, and 5 times 7 does equal 35. Then he took the 5 times 7 and substituted it in there and got the 74. And that works too. It's just a different way of reasoning through it. It's easier to have me show you and have you think through this way than explain this, because I can tell by the looks on your faces, some of you are like, I never would have thought of that, and I wouldn't have done it that way. And that's okay, right? Because there's different ways to approach everything. So thank you for sharing. Anybody have anything different with that? How many of you would prefer to do it this way? Okay, that's good. And how many of you would have done something like that? Anybody? Okay, all right. And see, it just depends, right, on what makes sense to you, so that's good. All right, so then let's look at number 2. I put number 2 on here because of the fractions, and I know the fractions freak you out. Is this that bad? What do you think? Or what would be the first thing you'd probably want to do? Get rid of the fraction and a fraction, maybe? Would you agree with that? Okay, so I can get rid of that. If I have, I'm going to rewrite that so you can read it. X over y equals x squared. Well, I'd like to kind of fix this. I could multiply both sides by y, but isn't this just the same thing as taking this and multiplying it by 1 over y? That makes sense? So this actually ends up being x over y squared equals x squared. Then what would you do? Any ideas? What are we trying to solve for? Y? Do I still need to get it out of the denominator? Yes. So I'm going to multiply both sides by y squared. So I get x equals x squared times y squared. Well, look, right here, if I had just multiplied both sides by y, I'd have x over y equals x squared times y, and then I multiply again, I'd end up with the same thing. So whether you change it to this or have multiplied by y to get rid of it, same thing. Now what are we trying to solve for? Y. So I'm going to divide by what? X squared, okay? So I get, oh, and guess what? It gave me x, right? X is 1/4. Can I substitute that in? Should I do it now or should I do it at the end? Does it matter? Doesn't matter either way. You want to do it now or you want to do it at the end? All right, you do it your way, now or at the end. I heard both. So you do it your way and I'll do it my way and we'll see if we agree. So the first time I worked it out, on my paper, I substituted it in right here, but here I didn't. I went ahead and just solved for x that way, because then I didn't have to worry about squaring fractions and dividing fractions and doing all that. I do end up with this, but then I end up here, so what's my answer? 2, or negative 2, it's plus or minus d. Can't be afraid of fractions on the PSAT. Let's see. The next one I want to do with you, because I'm going to skip some that are kind of the same over and over again, just because, actually, I do want to do number 3. We're going to do number 3. Because again, this is a system, because we're substituting things in that are variables. I have a equals this stuff, c equals b squared, and they want to know what a is. So I can substitute this in. So I'm just going to go ahead and substitute in this b squared. So a equals b over b squared plus b squared over b. So sometimes on these tests, you don't want to reduce all the way. Because if I reduce this all the way, then this is going to give me 1 over b, and it would give me b over 1, right? And I would still have to add these fractions. What I want is for this fraction to have a common denominator. Would you agree with that? Can I do that just in my reducing process? What if I just reduce this? B goes into b once, and then that makes this just b here, not b squared. Now they have a common denominator. Does that make sense to you? Do you see how that's all I did was reduce one of these b's out? So now that's equal to 1 over b plus b squared over b. And does that match an answer choice? It doesn't match it exactly, but it's the same thing, right? Even if you didn't end up writing down what was in pink, it's just this right here. Looks like a pretty hard question with all those fractions and all those variables, but all I had to do was substitute it in, reduce that one little thing, and not be afraid of the weirdness. You okay with that? Alrighty. So then, what do I want to do next? I want to do number 6 because I want to talk about another thing that kind of comes up on these a lot. When it talks about consecutive odd integers, right? Do you know how to represent consecutive integers? Do you even know what that means? Okay, consecutive integers would be 3, 4, and 5. Consecutive odd integers would be like 3, 5, and 7. Make sense to you? So they're consecutive odd integers, which means whatever x is, then y has to be x plus 2. If this is 3, it wouldn't be 4, it would be 5, because I would add 2 to it. Does that make sense to you? So you have to understand, consecutive integers, you add 1. If they're consecutive odd or even integers, you have to add 2 to get to the next one. And it tells me x is the smallest, then y, then z. So then that means that z is equal to, you could either say y plus 2, or you could say x plus what? 4. X plus 4. Okay, everybody okay with all that? So after I have that, it says, what is x in terms of z only? Which means x equals something with z's on it, only on it. So you got this, right? And if you solve for x, what do you get? Z minus 4. If y'all are much more comfortable thinking in terms of variables now than, before you, yes, you can substitute in fake numbers and do it that way, but sometimes that's a little bit longer than you just thinking through the quick little tiny algebra process that you're actually good at. Okay, we all good so far? Any questions? All right, so I want to look at number 7. When you write these things out, the math words that I know you've always known, you have to think about, what does of mean in math? Of always means multiply. Yeah. And then is always means what? So if I say x is 4, like that's saying like x equals 4. These two things are important. If you know that, you can write out these little equations, especially with percentages. Okay, with percentages, I say a sentence in my head so that I can write it down correctly anytime I'm trying to get the percentages right, because sometimes when you divide by percentages, things are weird. So this says 60% of A is, so 60% would be 0.6. 0.6 of multiplied by A is 20%, 0.2 of B. Does that make sense to you? Do you see how all you're doing is translating from English to math? But you have to know what these words mean mathematically, or you're not going to know how to set it up. So with percentages, is and of, the of is multiplied, the is equals. It sets you something up before I worry about anything else. Then it says, then B is what percent of A? So what I'm looking for is B is what percent of A? So basically I'm looking for X. Well, that's easy. All I really have to do here is to solve for what? B, right? If I just solve for B, won't I have some number times A? So to solve for B, what do? Divide by 0.2, right? Well, what's 0.6 divided by 0.2? Is it 3? Is it 0.3? It's 3, because 3 times 0.2 would be 0.6, right? And you have this 6, if you have 0.6 over 0.2, I could multiply that by 10 over 10, and that's a value of 1. So I really just get 6 over 2, and that's 3 as well. Okay? Remember that you can manipulate it that way. So what we get is B equals 3 times A. So then what is our answer? A lot of 3's in those answer choices, right? What do you think the answer is? Okay, this number right here, doesn't it represent a percentage? Because didn't this represent a percentage? So to take 0.6 and get it to a percentage, I move the decimal place over twice. So this 3, I got to move the decimal place over, it's 300%. So don't get lost in percentages and decimals. You know those things, right? This one's confusing, though. It stumped me for a second when I was working through it. I was like, wait, I know it's not 3%, but 300 just seemed wrong. It's like, I got to double check myself here. But if you think about it, 60% of this number is only 20% of this number, right? That means that this number is pretty small, and so it would make sense that B would be a whole lot bigger than A. Okay? We okay with that? Think about your decimals and percentages, because you can do these. All right, I want to look at number 9, because I almost took 9 off. I was trying not to put too many on here. And I'm going to give you the answers to all of these that you can work back through. But 32 times the square root of 32 equals a times b, where a and b are positive integers, and a is greater than b. That's important to know. Which of the following could be the value of a plus b? Here's something you want to pay attention to. Could be, which means there are more than one option. And so the first thing you can't come up with might not be the right answer. And so this is a, this would represent a and b. Well, clearly 32 plus 32, because I want a plus b, is not even there, and a is not bigger than b. What they want me to do is to simplify that square root. Well, isn't 32 2 times 16? Okay, so 16, if I take this out of here, what's the square root of 16? 4. So that would give me 32 times 4 times the square root of 2. What's 32 times 4? Actually, does it even matter what 30? It's over 100. Would we agree with that? Okay, so it's 120 what? 8. It's 128, but at least you know it's over 100, because I don't really care what it is. It's something over 100 plus 2. Is that even an option? No. So you see why that's actually finding the number is not necessarily even important. We just know that that's not it. So dang, I got to figure something else out. Well, instead of 2 times 16, what's another factor here? 8 times 4. So if I do 32, and that's like 8 times 4, then I can take the square root of 4, which is what? 2. And then 2 times 32 is 64 times the square root of 8. Okay, it's not simplified all the way, but it didn't say I had to. Then if I add those two, what do I get? 72. 72. Is that an option? Yes. Okay. So when it says could, there might be more than one option there, and you have to play around with the number. Now, one of the things that's always been popular is the symbol, and like actually means, and all you do is substitute. And if you've never seen it before, they kind of it's making something up. It's saying this. We know what plus, minus, and whatever means, but a weird arrow b is defined as this. Okay, so if that's the case, then 2 weird arrow 6, this is your little a, this is your little b, right? So then you just substitute it in. Substitute it in here, and that means I get 2 plus 6. And this over -4, which is super easy. But if you didn't know what the heck they were talking about, they just made up an operation. That's all they did. Okay. Everybody okay with that? And then we'll do 13 as well. 13 is the same idea. But so capital Z times A is 10 to the A power. Or not times, but capital Z, weird diamond A, is 10 to the A power. Capital Z, weird diamond B, is 10 to the B power. So Z, weird diamond A, is going to be 10 to the A power over 10 to the B power. So what is my answer here? Well, this equals this, right? And then I need to simplify. Do my 10s disappear? No. It's B. Because when you divide, your bases are the same, and your exponents, and you're dividing, you subtract them. So this is 10 to the A minus B power, and it's B. So you have to know your exponent rules. Maybe you need to freshen up on those a little bit. Good, 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 good. All right, so let's look at the next one. This is the greatest integer function that we actually skipped. It's not really implied by here, but even though we skipped it, it tells you what it is right here, so it doesn't matter. It says if the function, and this is not absolute value, it's got little weird brackets on it, that's probably easier to see on your paper, is defined as the greatest integer less than or equal to x. All right? So what is the greatest integer equal to negative 0.4? Negative what? What's the closest integer that's less than or equal to that integer? See, we got to know what integers are. Negative 1. Integers are your counting numbers, all right? So less than this is negative 1. That's the closest one. Then less than negative 3.7 would be what? Negative 4, okay? So it just makes everything whole number. But you're not rounding up. It's always the one right below it. Does that make sense to you? So it's the greatest integer less than or equal to. But it tells you that. So, okay, even if you had never seen it before, you got it. So then what's your answer? A. It's negative 5. But that's what greatest integer is. So then here, since that was a little confusing, I was going to leave this one for you to do, but we'll talk about it too. So this is greatest integer again. What's the greatest integer less than or equal to this? 1. What's the greatest integer less than or equal to this? 0. And so your answer is 1. Okay. Everybody okay with that? Yes. Okay. Now 16, that's another one of these weird little function ones, but we're going to do it anyway because it had something else in it I wanted to talk about. Okay. Oh, not 16, I'm sorry, 14. I took some off of my original one. So this is A, weird arrow B, right? Equals A squared times B cubed. So then if I have this, I'm just going to substitute it in. This becomes my A. So this is going to be 2 squared times negative 3 cubed. Before I do anything, this is going to give me a positive. Is this going to give me positive or negative? Negative. It's going to give me a negative, right? So when I multiply those two together, my answer is what? Negative. Those are not my answer. Even if I don't want to, hopefully you know what this is, but let's say something you may not just know. This clearly is 4. But even 4 times just 3 is bigger than 6, right? So that's not my answer either. Without actually even getting the numbers, my answer is D because I understand how it works. You with me on that? That's how you start to learn to process through things, being careful not to just eliminate anything, but okay. All right, so what about 15? Does 15 freak you out? Do you know what to do about that? Do you have time to sit there and add up all those integers? No. Okay, so let me give you a little quick history that we talk about in the second semester in pre-cal. But there is a mathematician that when he was little, he was in elementary school, and he was kind of a problem child because it was boring for him because he was like a little genius. So the teacher gave the whole class busy work, and their work was to find the sum of the first 100 integers. So basically add up 1 to 100. And so she was thinking it's going to take them a while to do that, right? And he was done like that. Because instead of just jumping in and doing the math, like a lot of us do, he was like, there's got to be an easier way. So what can I do? So he started listing out the numbers, like 1, 2, 3, 4. And then he started with 100, and he went backwards. Right? And he realized that this is 101, this is 101, this is 101, this is 101, right? So he got all the way down to 50 and 51, and he gets 101 there, right? Does that make sense to you? So what he wanted to do was add all those up and then not actually add them up, right? Because I do this, if I add these two together and multiply it by, what, 50, right? Which is half of what I wanted. That's n over 2. n over 2 gives me the 50 that I would multiply, right? Because there's 100 numbers, but I'm only going to 50, because then when I go to 51, I got 50 again, and I'm repeating it. Does that make sense to you? So there's n equals 100, because there's, well, I know it's 1,000 here, but I'm just talking about this one. N equals 100. So there's only 50 things I'm going to multiply, right? So it's n over 2, and I'm going to multiply that by, well, n is 100. All of that is n plus 1. Does that make sense to you? So that's the sum of the first n integers, or however many, whatever you want to do. So in this case, it's 1,000. So I've got 1,000 over 2 times 1,001. So that's 500 times 1,001. So what's 500 times 1,000? Would you say it's five? All those start with 500,000. So like, yeah, 500,000, right? Plus, what's 500 times 1? 100. So the answer is D. If this isn't something that you remember when you go into it, think through this and what he did. Okay, if you have time. If not, if you feel like it's going to take you forever because it doesn't make a whole lot of sense, then, but think through what happened here, and then that can help you come up with that. Because did you see how I came up with that from that idea? And that's what he did, and that's where that little equation comes from. You can see this differently sometimes too, like one big fraction, but that's that one happens. There's questions on there, so I wouldn't worry too much about it, but they do like those questions. All right, so let's look at 16. Do you want to actually multiply this stuff out? No. This is where your estimation, because the answers are far enough apart that I can estimate. I can make this 60, and I can make this 1,000. I can make this 30,000. When you do this, make sure you use enough zeros. Right? Before you multiply anything else out, these 3 zeros knock out these 3 zeros. This 0 knocks out that one because it's like dividing by 10. So in the end, I have 6 divided by 3. My answer's 2. Right? That makes sense to you? Okay, good. Alrighty, so then let's go to the next. Are we on the back of the second page now? Or no? Oh, shoot. Okay. What number? Okay, I lost my number somewhere here. Well, what question? Okay. Oh, okay. I did leave these on here. If x over 3 is an odd integer, then which of the following could not equal x? So I left these on here because you have to make sure, and you may not just know, but you can figure these out quickly, that an odd times an odd gives you whatever, even times even gives you whatever, and odd plus odd, that sort of thing. So you use easy numbers to make sure you can wrap your mind around it. And odd, so if I do 3 times 3, I get what? 9. So that tells you an odd number times an odd number gives you an odd number, right? Because the same thing is going to happen every time. And then if I do 2 times 4, that gives me 8. Even times even gives me even, right? Then when you think about addition, 3 plus 5 gives me what? 8. So odd plus odd gives me even. And then 2 plus 4 gives me 6. So even plus even gives me even also. Okay? And then odd plus even gives me odd. But when you need to know that, because you kind of have to have that idea to be able to answer these questions. And so if you just use quick numbers, you can process through that. Because it says if x over 3 is an odd integer, then which of the following could not equal x? Well, if it's supposed to be odd, then in order to get an odd number, what happens when I take an even divided by an odd? Like what if I took, well, even if I couldn't just come up with numbers, but there's only one even number here, right? So 18 divided by 3 is what? 6. And is that odd? No. So then that's my answer. They're good at asking questions where you substitute numbers in. It might just ask you what has to be true about the number. Well, it couldn't be even, that sort of thing. As these are all odd numbers, well, you divide all those out, you're going to get an odd number, and that's what you want. Okay? Does that make sense to you? So make sure you can process through these things, which I didn't have to know all of them for this one question, but sometimes you just want to know if your answer is going to be even or odd, and that's all you want to know. All right, I don't have much time left, so let me pick some. I'm hoping you're getting something out of this, because there was reasons I put ones on here. Okay, I do want to look at number 1. Does number 1 look a little scary to you if it's a non-calculator? Yes or no? It may not. Think in terms of decimals, right? This is 9. 9 over 100 is 9 hundredths, yes? So I would add to that point, this is my tenths, and then my hundredths, right? Then plus, this is 9 10,000ths. So I have tenths, hundredths, thousandths, 10,000ths, right? And talk yourself through each place. So now when I add these together, what do I get? C, right? You see how easy that is? I didn't even have to physically add them. I know how much y'all hate fractions. Look at number 2. You hate that one? Is it pretty easy? You have to know how to cancel before you multiply. Look at this. I can knock out the 7s. I can knock out the 8s. I can knock out the 9s. I'm left with 6 over 10, which is 3/5. Right? How many thirds are there in 2/5? Do you even know what to do with that? No. You make yourself a sentence. Right? how many thirds, so that means I could multiply 1/3 times some number. That's how many, that's if I have 5 thirds, it'll be 5 times that, right? How many thirds would have to equal 2/5? So then to get x by itself, I'm going to divide by 1/3, which is the same as multiplying by 3. And what's my answer? C, 6/5. Yes? All right, jump to 11. Do not multiply this out. Factor. In this numerator, can you factor out a GCF? What is your GCF? 5 to the 5th power. If you factor that out, you are left with 5 minus 1 over 4. I'll give you a second for that to sink into your brain there. Everybody with me on why I did that? Okay, so then that gives me 5 to the 5th times 4 over 4. Will those cancel out? My answer is D. Do not multiply that mess out, right? We factor stuff out of that. Look at number 6, since we have some time. Don't multiply that out either. 16 times, actually I'm just going to make this into times 18 over 8, right? And then I can reduce things. So I can say 8 goes into 16 twice. 18, I can divide a 6 out of there and have 3 left over, and that would leave me 2 here. This 3 can divide into 15 and leave me with 5. This 5 can divide into the 20 and give me 10. No, it gives me 4. Duh. And then these 2's cancel out, and what's my answer? 4. That's all I got left. I didn't multiply anything. Might help if I spaced it out. But think through that. Even I know I went through that fast because I'm afraid the bell's going to ring on me. But learn how to cancel before you multiply. It will help you greatly. Okay?